Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. In our earlier limit videos, we looked at the tangent problem, which asked, how do we find the slope of a curve at a single point? For a curve, the slope is constantly changing. So our strategy was, we first pick a point on the curve, and then we draw a secant line through a nearby point. Then we take that point and we move it closer and closer to our original point. And as the 2 points get closer, the secant line becomes a tangent line. Now, before we get into the formal definition, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. So this idea of zooming in and letting the distance shrink is exactly what limits are built for. And that is what brings us to the definition of a tangent line. So the tangent line to the curve y is equal to f of x at the point P, which we have labeled it as a, comma, f of a, so those are our x and y values. It is the line through P with the slope m is equal to the limit as x approaches a of f of x minus f of a over x minus a, provided that the limit exists. So let's take a look at this through a simple diagram. Let's say our curve f of x looks something like this. So here we have our f of x. And then let's say here, this is our point P. So we know that our point P has an x-coordinate of a, and it has a y-coordinate of f of a. Now let's say we have another point here, which we're going to call m sub 1. So that is going to have an x value of, let's call it x sub 1, and it's going to have a y value of f of x sub 1. So if we were to connect those 2 points, we would get a secant line like this. So we're going to call that slope m sub p to m1. So we know that the slope between 2 points would be the difference in y value over the difference in x value. So that's going to give us f of x sub 1 minus f of a over x1 minus a. Now what happens if we bring that second point closer? So let's say we have another point, we're going to call this m2, and we've brought it closer to p. So this one is going to have an x value of, let's call it x sub 2, and then it's going to have a y value of f of x2. So the slope of the secant line between P and M2, let's call that M sub PM2. That is going to be, again, the difference in their y value, and that's now going to be f of x2 minus f of a over the difference in their x value, which is x2 minus a. So what this limit is saying is that we're going to bring that second point closer and closer until the x value reaches a. But then we're still using the formula for finding a slope, which is the difference in the y value over the difference in the x value. Note that if this limit exists, there's actually another way to write this. And the other way would be to write this as equal to the limit as h approaches 0 of f of a plus h minus f of a over h. All this is doing is that instead of having another x value, we're saying that x is equal to a plus h. So on the diagram, that would mean the distance from a to our x value, that would be the distance h. So this is essentially saying that we're shrinking this distance here until it becomes 0, and that is going to give us the slope of the tangent line. And now let's take a look at how we can use this definition in an example. We want to find the slope of the tangent line to the graph of f of x is equal to x cubed at x is equal to 1 and x is equal to 2. So let's go ahead and write down the two formulas. The first one was we have m is equal to the limit as x approaches a of f of x minus f of a over x minus a. And then the second formula that we had was m is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. So we're going to use the first formula to find the slope of the tangent line at x is equal to 1, and then we're going to use the second one for x is equal to 2, just so that we get to take a look at both of them in action. So for the first one, we're going to get m is equal to limit as x approaches, and then our a value here is 1, and then we would have f of x. So our f of x is x cubed, and then f of a would be 1 cubed, so that'll be 1. And this is over x minus 1. And now we can use difference of cubes to factor out our numerator. So we get limit as x approaches 1, and this will be x minus 1 times x squared plus x plus 1, and we have over x minus 1. So now the factor x minus 1 can cancel, and we're left with the limit as x approaches 1 of x squared plus x plus 1. And here we can just do a direct substitution, and we get this is equal to 3. So this one is for the slope at x is equal to 1. And then the second one, that would be for at x is equal to 2. And we're going to be using the second formula. So then we get m is equal to the limit as h approaches 0 of, so now f of a plus h, well, our a here is equal to 2. So then this would be 2 plus h cubed minus f of a, which would be 2 cubed, so that'll be 8. And this is over h. Now we need to go ahead and expand out the 2 plus h to the power of 3. So you can either do that on the side, which would be 2 plus h times 2 plus h times 2 plus h. Or if you're familiar with the binomial theorem, you can just use that to expand it. So then that would give you the limit as h approaches 0 of 8 plus 12h plus 6h squared plus h cubed. So that's the expansion. And then we have minus 8. And then this is all over h. And now we can see that we have 8 minus 8. So they'll cancel. And then we can go ahead and factor out an h from each term on the top. So we get h times 12 plus 6h plus h squared. And we have this is over h. So now we can cancel out the h on the top and the bottom, and this becomes limit as h approaches 0 of 12 plus 6h plus h squared. Okay, so let's just go ahead and put brackets around those. And now we can go ahead and do direct substitution here. So we end up with this is equal to 12. Now for the second part of this example, it says to use the slopes found in the previous question to find the equation of the tangent line at each of these x values. So we had at x is equal to 1, our m value was equal to 3, and then our y value would be 1 to the power of 3, which is also 1. And then at x is equal to 2, the slope that we found was equal to 12, and then the y value would be equal to 2 to the power of 3, which would be 8. Now the equation of a line when we're given the slope and the point would be to use the point-slope form. So the slope-point form says that the equation of the line is y minus y1 is equal to m times x minus x1, where x1, y1 is the point. So now for our first point, that would be 1, 1 with a slope of 3. So using this formula, we get y minus 1 is equal to 3 times x minus 1. And then for our second point, that would be 2 comma 8, which means the equation of the tangent line is going to be y minus 8 is equal to 12 times x minus 2. And feel free to just leave your answer as that. We don't need to change them to the slope-intercept form. So now all of this motivates our formal definition, and that's probably the most important one in this limits chapter. And that is the definition of a derivative. So this definition says that the derivative of a function f at a number x, and that is denoted by, we read this as f prime of x, and is defined as f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So notice how this is very similar to that second formula that we wrote down. The only difference here is instead of a particular value for x, which we have called a before, we're now just using x. So let's take a look at how to use this definition to find f prime of x if f of x is equal to 1 over x minus 1. So we start with f prime of x is equal to the limit as h approaches 0 of f of x plus h, so that's going to be 1 over x plus h minus 1, minus f of x, which is 1 over x minus 1, and we would have that over h. Okay, so since our numerator is a fraction minus a fraction, let's go ahead and put them over a common denominator first. So we get this is limit as h approaches 0 of, so we're going to multiply that first fraction in the numerator by x minus 1 over x minus 1. So then we get x minus 1. And then our second fraction, we're going to multiply that by x plus h minus 1. So that becomes minus x plus h minus 1. And then now they have the common denominator of x plus h minus 1 times x minus 1. And this is still all over h. Now we can simplify our numerator a little bit. So we can see that we have x minus x, so that'll cancel. And then we have a minus 1 minus a negative 1, so that will also cancel, which means we're just left with negative h on top. And then we can also go ahead and move this h here. So then we get this as negative h over, and we get h times x plus h minus 1 times x minus 1. And now this is going to allow us to cancel the h on the top and on the bottom. So we're left with limit as h approaches 0 of negative 1 over x plus h minus 1 times x minus 1. And now since we're no longer dividing by 0, we can go ahead and do our direct substitution. So we end up with this is equal to negative 1 over, and once we substitute in h is equal to 0, we would get x minus 1 times x minus 1 on the bottom. So that gives us x minus 1 squared. So our final answer is f prime of x is equal to negative 1 over x minus 1 squared. So why is this useful? Well, this gives us a general formula for finding the slope of the tangent line at x for the curve f of x. And once we find this general formula, it doesn't matter how many different x values you throw at me. All I need to do is substitute in that value in, and I can find the slope. Remember how for the earlier example, we were asked to find the slope at 2 different points. One for x is equal to 1, and one for x is equal to 2. And we had to go through the entire process twice. But using this general formula, we would only need to go through the process once, and then we can just substitute in the number. So now let's go back to that previous example of when our function was y is equal to x cubed, and see how we would do that. So using the definition of a derivative, we would get f prime of x is equal to limit as h approaches 0 of, this would be f of x plus h, so that's going to be x plus h cubed, minus f of x, which would be x cubed. And we have this is over h. So same thing, we are going to go ahead and expand out x plus h cubed, either doing it step by step on the side or using the binomial theorem. So using the binomial theorem, that would be x cubed plus 3x squared h plus 3xh squared plus h cubed. And then we would subtract the x cubed, which is this part here. And then we would have this is all over h. So now the x cubed is going to cancel. And then we can see that there is an h in every single term on the top, which means we can go ahead and factor that out. So we get this is h times 3x squared plus 3xh plus h squared. And then we still have our denominator, which is h. But now we can cancel out the h in the numerator and the h in the denominator. So we get this is limit as h approaches 0 of 3x squared plus 3xh plus h squared. And now this is going to allow us to do a direct substitution because we're no longer dividing by 0. So once we substitute in h is equal to 0, we end up with this is equal to 3x squared. So now if we want to find the tangent line at x is equal to 1, the first thing we need to do is find the actual point there. So we would have y is equal to f of 1, which is going to be 1 cubed, which is equal to 1. So therefore, our point is 1, 1. And then the second part would be to find the slope at x is equal to 1. So the slope is going to be equal to the derivative at that x value. So that'll be f prime of 1. And since we already have the formula for f prime of x, we can just go ahead and substitute 1 into this expression here. So we get this is equal to 3 times 1 squared, which is equal to 3. And now we can go ahead and use the point slope form to write out the equation of the tangent line. So we get this is y minus the y value of the point is equal to the slope times x minus the x value of that point. And then just for fun, even though this question didn't ask for it, but if we needed to find the equation of the tangent line at x is equal to 2, we would do the exact same thing. We would say the y value there would be y is equal to f of 2, which would be 2 cubed. So that's going to be 8. So that means our point is 2, 8. And then the slope would be m is equal to f prime of 2. So then that would be 3 times 2 squared, and that is going to be equal to 12. So therefore, the equation of the tangent line would be y minus 8 is equal to 12 times x minus 2. So notice how when we needed to find the equation of the tangent line for the second point, we didn't have to go through this entire process again. All we had to do was substitute the value 2 into the expression for f prime of x, and that gave us the slope. So now let's go ahead and do a quick recap of what we covered in this video. We learned that tangent slopes come from limits of secant slopes. It's what happens when the second point gets closer and closer to the first point until they overlap. And we learned the definition of a derivative, which is that it's defined using a limit as h approaches 0, where h is the distance between those 2 points. We learned that the derivative measures the slope and the rate of change. And finally, the connection between tangent lines and derivative is that the slope of the tangent lines come directly from the derivative at that particular point. And now it is your turn to give this a try. Can you find the derivative using the definition of this function here, and then use it to find the equation of the tangent line at x is equal to 1? Make sure to leave your answer in the comments below, and let us know what other calculus topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.